I think you have seen that if you differentiate x square plus 1 and if you differentiate x square plus 2, so sir, in both the cases, what do you get?
Both the cases we will get 2x only.
We will get 2x in both the cases. So what can we understand from here? That if you add any constant to x square, that does not make any difference after differentiation.
Yeah.
Because
when the value of differential will remain same whether some constant is added to the function or not.
Yes. So basically, if I want to do the reverse, that is integral of 2x. Okay, this portion, I am integrating this. So can we say that it is coming x square plus 1 or x square plus 2, or also differentiation of x square is 2x. So there is no one function which is coming. X square is also the integral of 2x, x square plus 1, x square plus 2, x square plus any constant.
So there are infinite possible value, and that can be depending on the situation.
So there are infinite possible values for the integration of 2x, not only one value. So what we do in indefinite integration, we write it like this: x square plus c is the integration of 2x. So if you differentiate a function fx and you get 2x, so that function is basically x square plus c, and you can write that function is 2x, which is dx. This is, yeah, so this is 2x dx, which is x square plus c. So what we see over here, that 2x when integrated gives a value which is not a unique value, unique expression. Now mathematically it is not very much difficult, because if you see this, let us draw all of this. So we take the graph of x square. Here this is x, and here there is a function fx. So I am drawing x square graph. Then I am drawing x square plus 1 graph. Then I am drawing x square plus 2 graph. All are shifting upward. If it is a negative sign, suppose, x square minus 1 will shift downwards.
So this is the value of c here. Whatever is the value of c, in case it is 1, here it is 2, and so on.
So on.
Okay.
So this is actually c. C could be 0, 1, 2, 3, or any real number. So basically what it resembles, that at any axis x, if we draw a line parallel to y-axis, so basically x is same everywhere because it is a line parallel to y-axis. So if we draw a tangent here, 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 what do we observe basically? That for same x, all of these curves are giving you the same parallel set of tangents. That means the slope is same. This line is also making theta angle, this is theta, and this is also making theta angle. So the derivative of any of these curves at the point x is same. What do you understand by this figure? I am again saying the derivative of any of these functions at the same x is always same, which is actually 2x. So if you differentiate this 2x, this 2x, this 2x, everything is 2x. So integral of 2x is any of these functions basically.
So the definite value will come only when we know exactly from where to where we have to integrate.
Yes.
Here we don't know we are integrating from which point to which point. So the constant is a general value which can be anything. But when the initial and final condition is known, then we can exactly find what is the value of c in that case.
And that can also be interpreted like some other words also, like in physics also you get many such situations that you have to you have been given a relation and you have to find a value.
Yeah.
And it is given that find it at t is equal to 3 seconds. At a given time. So in that situation, it helps us to find the value of this c. Because each of these curves are actually under differentiation same thing. But if you give some extra condition, like I give you, that you have to find a curve which is passing through a point 0, 2, suppose.
Okay.
So in that situation, now you have not a family of curves, but one specific curve, because if you will take x square plus c as a function, y is equal to x square plus c, and you put x is equal to 0 and y is equal to 2, the value of c is 2.
Okay.
So the function is basically y is equal to x square plus 2. So the graph which we have to accept here is this one, because this is passing through the point 0, comma 2.
Okay.
So we need to have some extra condition to exactly find which curve we are talking about.
Okay.
So I think this was the introduction to integration for these students. So let us give them a homework.
Yeah.
And then we will also relate in the next lecture that how integral is related with physics.
Yeah, there are various applications of this indefinite or definite integral of physics, and that is a very common thing. Right from the chapter kinematics to every chapter, you will see that integration is very important, and every quantity can be related. Which quantities were first calculated using differentiation can be inversely related with the integration also. So we'll discuss all those
We will
things,
study. For homework you can do in the next lecture and present before us what is the integral of a function x to the power 5 dx, and also what is the integral of x to the power n dx. So this is a specific situation, this is a general situation for all n belonging to real number, except here we don't take -1. There is some anomaly there that we will see later on. Otherwise, there is a general formula, and then we will also study physical aspect. So that is all for this lecture from us students. Pawan sir and Subbu sir take leave right now. Thank you.
Thank you, students.